Hello, stats students. Welcome back to Chapter 7. We are in the last section of Chapter 7, so confidence intervals. And we have a new type of confidence interval to look at. So we've been talking about the population mean or the population proportion, but Section 7.4 is about variances and standard deviations. So we have a new table. We don't have Z's and T's. Now we have a chi-square table. So if you think about manufacturing, right, we want everything to be perfectly fit together. If you're looking at nuts and bolts, they have to fit together. It's important that the product dimensions are consistent so they'll fit together. Or if we're thinking of medicine, we want to have as little variation as possible because we want to make sure everybody gets the same dose. So therefore, we have to have confidence intervals for variances and standard deviations. So we're not talking about population mean. We're talking about the variance, the difference, how varied our values can be. So we have a whole new critical value. It's called chi-square. Looks kind of like a squiggly X squared, literally squared. So, and this is what a chi-square distribution looks like. Notice it is a very right or positively skewed graph. All of my data appears to be on the left side of the graph, and it's getting pulled to the right or the positive direction. So first of all, notice my x and y axis. All my chi-square values are greater than or equal to 0. So no negatives for chi-squares. This is a family of curves, and it's based on degrees of freedom. We've talked about degrees of freedom. The larger the sample means a larger degree of freedom, means that our graph gets varied, gets pulled farther to the right. Notice our degree of freedom of 1 or 4 on this example. They are very tightly put together. Our data is very close together. Every area under each chi-square distribution is equal to 1. We know that, right? That's how our population, or how our standard Z distribution is. If I just look at this curve right here, this whole area is still equal to 1. So that hasn't changed. It's just a different shape with the positive skew. And last but not least, everything is positively skewed for chi-squares, which I mentioned way up at the start. So that's what a chi-square distribution looks like. Chi-square goes with standard deviation and variance. So here's what the formula looks like. Here in section 7.4a, we're just going to find the critical values. We can, in 7.4b, make the confidence intervals because it is a little bit different. So if I'm looking for my chi-square values, first of all, it's table G in our book, Appendix A, which I believe is page 782. It's a one-page table, and it's right after our T table, our T distribution. We use degrees of freedom. So our n-1, which we know, df equals n-1. We use our confidence level still, and we use alpha. Remember, alpha comes from our confidence level. We can go back and forth between them. The curve is not symmetric. This is our huge difference with chi-square values. So we actually have to find two different values, our chi-squared left and our chi-squared right. It's not equal, just like it's not a symmetric curve. So we could, for our t's or for our z values, just do our plus and minus the margin of error and use that critical value. Well, these are two different values. Because it's positively skewed, they're not perfectly symmetric. They're not the same value. So two different values to find, and we'll talk about how to find those. Hopefully everybody knows at this point that alpha is equal to 1 minus the confidence level, or if you prefer 100% minus whatever it might be, 95%. So here's what we do. To find chi-square right, this value over here, we just take our alpha over 2 and we go to table G. If you look at the chi-square table on page 782, it shows that the area is shaded to the right. So it's unusual, it's opposite from what we do. So we just look up in table G whatever our alpha over 2 value is. We're still splitting that alpha. We still, if we are 98% confident here, we still have 2% not confident, right? So our alpha would be 0.02. So our alpha over 2 would be 0.01. Well, we would look up that 0.01 over here. To find our chi-square left, we do 1 minus the alpha over 2. And then we go to table G. So 1 minus a 0.01 for this, 1 minus alpha, minus alpha over 2 would be like a 0.99. That's the value that we take to table G. And if the number of degrees of freedom is not given in the table, use the lower value. Go to the next lower. I believe the table only goes up to 30, so if you've got a sample size of 35, you're just going to go down to 30. There isn't a lot of option there. All right, so I know that this is messy and confusing, but let's do a couple examples. Our goal in 7.4a is to have you understand how to find your chi-square values, both of them. So let's do a couple examples, and then we can worry about using those in our confidence intervals in the next section. So example 7.13, find chi-square left and chi-square right. Notice it says alpha is equal to 0.05. Everybody knows, right, that I'm talking about a 95% confidence level. I already just gave you alpha. If n equals 6, everybody knows that our degree of freedom will be equal to 5. So I write down my chi-square left and chi-square right. It's actually really important that you distinguish between them, because if you don't, you're going to use the wrong numbers when you go to make your confidence interval. So I do a little bit of side math. This is where I'm going to put my answers for my chi-square left and right, but I need to know what I'm looking up in my table G. So alpha is equal to 0.05. So alpha over 2 is equal to 0.025. So when I go to table G, I'm going to look up 0.025 for my right. And then I'm going to do 1 minus the 0.025, or I'm going to look up a 0.975 for my left. Notice when you're on the chi-square table, you've got your degrees of freedom that you're going to look down that row. And our chi-square left values are on the left side of the table. Our chi-square right values are on the right side of the table. So if that helps you at all, maybe it will. There's our rights. So I am going to go to a degree of freedom of 5. Let me just highlight this so that I can keep track of it on the board here. Here's degree of freedom of 5. I have to look up 2 separate things. So for chi-square left, I'm looking up a 975. So 975 gets me a 0.831. For my chi-square right, I'm looking up so that's my left. For my right, I'm looking up a 0.025. So I'm going to go down to my degree of freedom of 5, and I've got a 12.833. There's my chi-square left and right values. It's not symmetrical, but the best I can do is split that alpha between the 2 values and look up from there for my critical values. So there's our first example. Get a system that works for you. I write down these 2 things. I put this over on the side when I do my math, just to make sure before I look up on my table I know what I'm looking for. The confusing part is subtracting the alpha over 2 from 1. So make sure you do alpha over 2 and then subtract from 1. So letter B, let's find chi-square left and right for a 95 or 90% confidence level, and n equals 25. So we know that our degree of freedom is equal to 24. We know our alpha. I'll go over here. So 90% confidence, so that means that alpha is equal 1 minus 90%, right? Or 100%. So I'm asking how unconfident are you for our alpha? So I'm 10% not confident. So I'll put in equals 0.10. So alpha over 2 is equal to 0.05. 0.05 is what I'm going to use then for my chi-square right. So let me jot this down. Chi-square left, chi-square right. And we just did a quick calculation. Our alpha over 2 was 0.05. That's what I look up in my chi-square table. And then remember 1 minus alpha over 2 for this side. So that's going to be a, what, 0.95? So I'm going to look up a 0.95 on this side. So I go down to my degree of freedom 24. It's way, way at the bottom of my page. So when I looked these up, let me tell you what I got. For my chi-square left, I got a 13.848. And for my chi-square right, I ended up with a 36.415. And I've got myself my 2 critical values that I'll need next time to make my confidence interval. Double check, make sure you're seeing the same numbers. Don't forget to use your degree of freedom. Let's do this last one real quick here. I didn't put a picture next to this one, so let's just do C. It says to find the chi-square left and right for a 98% confidence level. So chi-squared left. You need to make sure you differentiate which one's right and which one's left. I know it's a pain, but write it down. So degree of freedom equals 11. Alpha equals 2%, right, or 0.02. Everybody knows where alpha's coming from, right? Hopefully we've got that part. So alpha over 2 is equal to 0.01. That's what I'm going to look up for my chi-square right. 1 minus that would be a 0.99. That's what I'm going to look up for my chi-square left. According to my calculations, it looks like it's a 3.053. Tell me if I'm wrong there. For my chi-square left and my chi-square right, I got a 24.725. All right, I think we're good. Hopefully you've got this figured out. It's not super tricky, but you just need to be careful about the alpha over 2. Once you've got finding your chi-square values, we are ready to go into confidence intervals in 7.4b. So thanks for hanging around, and I'll see you next time.